Hey guys, today we'll talk about vectors again. So we'll talk about some further ideas that we'll explore in vectors. Now we talked about a bunch of these ideas uh, in 10th grade. We'll just talk about some more of them. This notation, if we find this written, then this is referring to the magnitude of the vector v, right? It just refers to the magnitude. But usually we just go and write magnitude of v with single lines. The magnitude, some properties of the magnitude, it's always positive. So if you have a vector like negative v, this negative means that you're talking about direction. But the magnitude of the vector is always positive. If two vectors are opposites, they have the same magnitude. If you have a vector going this way and it's opposite the vector going that way, their sizes are the same, so they have the same magnitude. The product of the magnitude of the product of two vectors, as you can see down here, is the same as the product of the two magnitudes of the vectors. So if you have a times v, if you have a scalar, a is a scalar here, this is a scalar times a vector, and you're finding its magnitude, then that's just the same thing as finding the magnitude of that scalar, so ignoring the negative sign if the scalar has a negative, and multiplying that by the magnitude of the vector. We'll see that in examples. So if I want to find the magnitude of this vector, so remember these vectors are, it's going over 2 units on the x and 1 unit on the y. So that means its resultant vector, or it's, the vector is that one over there. It has an x component of 2, a y component of 1. If I try to use Pythagoras and I want to know this magnitude, the size or the length of that red line, then that size is just going to be x squared plus y squared, or I squared plus j squared. So I'll just find 2 squared plus 1 squared, square root, square root, Pythagoras, square root, and that gives me 4 plus 1 is 5. So the magnitude is the square root of 5. How about the direction? The direction of a vector can still be found out because it's the angle with the positive x-axis, right? It's the angle with the x-axis. Usually the angle with the x-axis, but depending on the application, you can still figure out what angle you're talking about. So we're trying to find this angle with the x-axis, and I hope you can see we can draw a right angled triangle in which the x value is a and the y value is b. And from that triangle, the tan of the angle, which is the direction, will be b out of a. So to find direction, you just use tangent. Find the magnitude and direction of this vector here. Let's first sketch the vector. 2 units on the x, so 2 units. This is 2 units going up to there, and negative 5 units on the y. So 1, 2, 3, 4, 5. Negative 5 units on the y. Obviously, this vector, these are its components, its I and j components. So the vector is going down there, and its angle with the x-axis is that angle over there. So this is negative 5, and this is 2. Now, this angle has to be found on 0 to 360. So that means I'm going to find the angle going around. What I mean is starting from here, going all the way up to there. Because if I try to get the small inside angle that I see, that will be a negative angle. From that triangle that I have, I hope you can see that tan of the angle, the acute angle I'm looking for, is negative 5 divided by 2. And if I find the inverse tan of this, let me just do 5 over 2, inverse tan of 5 over 2. I'm ignoring the negative because I know that the negative simply means that this angle is in the 4th quadrant, right? This negative helped me to draw my sketch and show me that the angle is in the 4th quadrant. But when I calculate the inverse tangent, this is inverse tangent of this angle, and I get inverse tangent 2.5. I get 65.6 degrees. I know that that angle is the inside angle here. This is 65.6. So to find what the actual angle that this question asks for is, to find that green angle, I'm just going to take away the 65.6 from 360. So the direction of this vector, the direction is change to blue. The direction is so I'll take 360 minus 65.5, which will be 354. Oh, sorry, 65.6.4, I think. Subtract 360. Oh, 294. Sorry, what? 294.4. I got this very wrong. 294.4. How was I even thinking? Alright, so that's how you find the direction of a vector. A unit vector is any vector with a magnitude of 1. If a vector has a magnitude of 1, it's a unit vector. U is the symbol that we use for a unit vector, because U. And if I want to find a unit vector that's in the same direction as any vector, I just find that vector and divide that vector by its magnitude. So if I divide any vector by its magnitude, I get a unit vector, i.e. a vector of 1 unit. So if I want to find the unit vector of this V, first of all, remember I'm using a vector divided by its magnitude. So I need to first find its magnitude. So the magnitude of V is 3 squared plus 4 squared square root, which is 5. Remember Pythagoras, or just I squared plus G squared square root. So the unit vector U for the vector V will be 3i plus 4j all divided by 5, which is the same thing as 3i over 5 plus 4j over 5. That is the unit vector. If you draw this vector on your graph, you'll find that it has a length of 1 unit. And you can prove that by by using Pythagoras to do 3 out of 5 squared plus 4 out of 5 squared. That will give you 1 if you follow the math properly. Alright, so some real life vector applications, velocity, which is you guys move every day on borders or borders, vehicles, airplanes. It always goes somewhere at a certain speed. The speed is the magnitude of the velocity. So your velocity vector really tells you both your speed and your direction. The force vector, if you push something, you cannot, I don't think you can apply a force to something without specifying or knowing or predetermining what direction you're applying that force to. So that's some applications. Let's look at some examples. I have a bullet fired at 560 kilometers per hour at 60 degrees above the horizontal. So 60 degrees above the horizontal, 560 kilometers per hour. They want me to write this vector in component form. So they want me to simply get its x component and its y component. So since it's a vector, it will have a y component and an x component. I'm just going to treat this like a triangle. If it's a triangle and I want the y component, I'll use SOHCAHTOA. So sine of 60 will be the y component divided by the hypotenuse, and the hypotenuse is the size of the vector. So I end up saying that y is equal to 560 sine of 60. And if I follow the same thinking to find the x value or the x component of this vector, I'll say cosine of 60 is equal to x divided by the hypotenuse, which is 560. So x is equal to 560 cosine of 60. I've got the two x and y components of this vector. I can plug them in a calculator and get the answer. But what I want you to notice is that to get the y component, generally, you will just have to take the vector times the sine of the direction. And to get the x component, the other one was y. To get the x component, you simply take the vector times the cosine of the direction. This idea, or what we've just done here, is what is known as resolving a vector, breaking it down into its x and y components, or I and j components. That's resolving a vector. So like I was saying, if you know the magnitude and the angle between the vector and the horizontal, then the vector will be, in component form, the vector will be v is equal to its magnitude times the cosine, times cosine of the angle plus sine of the angle. Where does this come from? I showed you on the previous screen that the y component was 560 sine of 60, and the x component was 560 cosine of 60. So if I want to write the vector in its I and j components, I'll write the vector v as v is equal to, instead of a, I've calculated a is the x component and it's 560 cosine 60. I'll have 560 cosine 60 I plus 560 sine 60 j. Now what you see is that 560 is common, so I can take it outside, and I'll be left with cosine 60i plus sine of 60j. Now 560 is the size of this vector, so that means that's the magnitude. So that's where this is coming from. The magnitude, that's the magnitude of the vector. The cosine, that's the x component, and the sine, that's the y component. This is just a general way of writing that expression, resolving a vector. Now this happens a lot. You guys throw balls every day. You play soccer, you play other fun games besides basketball. Maybe you've seen someone shooting a cannon, but what happens practically is that whatever is in motion and it's off the ground, if something is off the ground and in motion, so traveling like a projectile, there's basically two aspects to its motion. It's both traveling downwards, right? It could be up and downwards depending on what the motion is, and it's also traveling x-wise, right? Vertically, if this thing is short, it goes up for a little bit and then it comes back down, right? Its path is kind of like this. So you can say that it's vertically moving, right? It's vertically moving because it's changing position vertically, but it's also horizontally moving, so also changing position horizontally. Now, if I can think of a parameter that is unique or the same for both of these motions, that parameter can help me harmonize this motion and find equations that work for this motion every time. And that's the basic idea of parametric equations, but we'll talk about them in the next couple of lessons. That's the basic idea of parametric equations, that when this thing is traveling, the time it takes for it to move from here to here, right, to fall that vertical distance, the time it takes for it to do that is the same time it takes for it to travel the horizontal distance, right? So introducing that uniform parameter, the parameter t that unifies both of these motions, can allow me to solve for problems like this. Trajectory, ballistics, I can solve for problems like this using that idea. So as you can see, this object that is shown in this diagram has a constant horizontal velocity. Its horizontal velocity is the same at every point, right? And why is that? Well, the physics guys will tell you that that's because horizontally, as soon as it leaves the cannon, it doesn't have any more horizontal acceleration. It doesn't have anything pushing it horizontally. It only has its initial horizontal velocity. But vertically, it has gravity pulling down on it, so its speed vertically is going to change. If it's going up, its speed will go down. If it's going down, its speed will go up, right? As you will see, if it's going down, its speed will go up, and these speed values keep going up. The negative is for direction,